First and foremost, this experiment demonstrates how water can absorb heat and protect material like a balloon from burning or popping when exposed to fire. Normally, a balloon bursts instantly when touched by a flame, but when filled with oil or water, it remains intact, at least for a while. This experiment demonstrates heat transfer, thermal conductivity, and the high specific heat capacity of water. Why does this happen? Oil or water has a high specific heat capacity, meaning it absorbs a lot of heat before its temperature rises significantly.
Materials: rope, oil, water, funnel, candle, matches, and balloons.
Label all the 3 balloons with A, B, and C. Fill balloon A with air. Repeat the second step by filling balloon B with water and balloon C with oil. Tie all the balloons with a rope. Hang those balloons like this. Experiment 1. Light the candle under balloon A that contains air and observe. Experiment 2. Repeat step 6 with balloon C that contains oil and observe.
A few moments later.
Experiment 3. Repeat step 6 with balloon B that contains water and observe.
One eternity later.
Why we blew that candlelight? Because the balloon won't burst. Why? Let's discuss.
The observation for balloon C should be that it pops relatively quickly when exposed to the flame. This phenomenon can be explained by the thermal properties of oil, particularly its specific heat capacity as highlighted in our video. As indicated in our video, oil has a significantly lower specific heat capacity compared to water. The definition of specific heat capacity is the amount of heat energy required to raise the temperature of 1 kilogram of a substance by 1 Celsius. A lower specific heat capacity means the substance needs less heat energy to increase its temperature by a certain amount. When the flame is applied to balloon C, heat energy is transferred from the flame to the rubber of the balloon, and then quickly to the oil inside. Due to its low specific heat capacity, the oil absorbs this heat energy and its temperature rises very rapidly. This means the oil inside the balloon becomes hot much faster than if the balloon contains a liquid with higher specific heat capacity like water. As the oil rapidly gets hot, it transfers this heat efficiently to the inner surface of the balloon's rubber at the point of contact. Rubber has a relatively low melting or ignition point compared to the high temperatures the oil can quickly reach. The rapid increase in the oil's temperature and its subsequent quick transfer of heat to the rubber causes the rubber to reach its critical temperature, the point at which it weakens and ruptures very quickly. Therefore, balloon C filled with oil will pop much faster because the oil effectively and quickly conducts the heat from the flame to the balloon material, leading to its rapid failure.
Without oil or water, the flame directly hits the thin rubber, weakening it and causing it to burst. With oil or water, the rubber stays cooler because the heat is continuously drawn away by oil and water. The specific heat capacity of oil is 1820 joule, while specific heat capacity for water is 4200 joule. That's why balloons that contains water stay longer than balloons that contains oil.